You might be wondering what this problem is. Let's solve it today. Yeah, of course, it's a medium problem. I know it will take time, but I hope we can do it easily. Let's start the timer. Given in the question that we're having an array nums, which is of integer data type, it contains only positive integers. We call a subarray nums nice. So a subarray of the array would be called nice if if the bitwise end of every pair of the elements that are in different positions equals to 0. Okay, this is on bit manipulation. We call a subarray of nums nice if its bitwise end of every pair of elements that are in different positions in the subarray equals to 0. So now 1, 3, 8, no, 3, 8, 48. They have taken this array. 3 and 8 bitwise end is 0. 3 and 48 bitwise end is 0. 8 and 48 bitwise end is 0. Okay. Return the length of the longest nice subarray. A subarray is contiguous part of array. Note that subarrays of length 1 are always considered nice. Yeah, that's sure. So, so any subarray of length 1 is chosen because it is the longest here. So now, how do we know? Okay, we don't know how to take AND operation in Java. Let's do one thing. I don't know how to do bit manipulation in Java, so I'll just look into it once. 3 and 8. Okay, that's it. Guitar is an operation as this. So guys, the blue both of these that comes into my mind is the only brute force approach that's coming into my mind is you can use direct AND operation. So int I here int I equals 0, I less than no, that's not the case. See, whenever we check 3, 8, 4, mutual AND operations are 0. 3, 8 is 0, 348 is 0, and 848 is 0. So if AB is 0, AC is 0, it's sure that ABC will be 0, right? Let's check 3 and 8 and 48. Okay, so we don't need to check it multiple times because if A and B is 0, then A and B and C is 0. So what if we take this? Hmm, any number with itself will be 0. That's the basic AND operation. Okay, we're sure that if everything is 0, like the number with itself will be 0, the adjacent element should be 0. Hmm. Mhm. 3 and 8 and 10. Can we do that? And 10. Let's run this. Let's just showing. So this logic won't work here. We're gonna check individually, but we can't finish it in a single loop. Okay. So this will be a big of n log n big of n square solution here. Int I equals 0, I less than num star then a plus plus. Now after taking an element, I'll take others. For int j equals 0, j less than num star length j plus plus. Now this begins with I plus 1. Now let's take this variable count. First we take 1. With 1 anything is possible. 1 with 3 is possible. So let's take count variable here only. Int count equals to. If 1 is considered, consider it 3. So initialize this with 1. If, if I, oh shit, nums of I and nums of j equals to 0. Then count plus plus. We take with 1, 1, 3, not possible. Hmm. So this might not work because it should be consecutive. If 1, 3 is not working, we just need to break the loop. So we just need to break the loop. Else break. Let's go to next bit. 3. 3 and 8. It's 0. It's working. Next 3 and 48. Yeah, it's there. 3 and 10. No. 3 and 48 are working. 3 and 8 are working. So we need to check 8 and 48 also. How can we do this easily? I mean, see, we're going to take permutations and combinations here. Sliding window. Sure. Okay. Take this. First check. Okay, we take 1, 3. I got it now. We need to use sliding window here. Int start 0 and end 0. So see, this is a concept of sliding window. First we take two elements in the array. So int I equals to 0 start I less than and do we need to take I less than n? No, I less than num dot n I express. What do we need to do here? Nums of I plus 1 and nums of I equals to 0. If that's the case, and express. See, if 3 and 8 are there, we moved and then we need to move end again. Yeah, we moved end. Nums of start and end of the matter. Nums of start and of end. Consider zero. Initially it is here. You take what if it's a singular array? That would be an edge case, right? We take it, we declare it one. If dot then it's equals to one. Return one. For equals zero. Now consider the first case where end operation of 1 and 3 is not 0. So what are we gonna do? If nums of start and nums of end was 0, then that else now what do we need to do? We need to update start plus and also needs to be updated. And both are updated. So end would be 8, start would be 3, and if both of the end operations are positive, I mean both of the end operations is positive, then we do n plus plus and we check both. It's done. Now what do we gonna do? Mhm. 3, 8, okay. 348, okay. Now let's mm, even here we have something. See if 3, 8 is okay and 348 is okay, then we need 310. If it is not equals to 0, we're gonna check. Okay, we just update it. We have checked 38 and 348, but how to check 848? Okay, whenever we find this happening, we just do and this right. After this, we can use a loop now for in start equals to start. That's the C plus plus equals to this if nums are j plus 1. Okay, okay, okay. This needs to be done recursively here. It's just 3, so we're just dealing with 848. And the end operation should be done. Okay, 38, 848. And again, if there are four elements, 3, 8, 48, 56, 3, 8, 3, 48, 56, then 848, 856. Okay, so I don't think this needs to be valid. This is for one case. I mean, you get a start and end pointer of a valid thing. Now we're going to check that for what we need to do. This is the recursive function that we're gonna do. Wait, recursive in the we do. So after each of this, what we need to do? After checking the image, we take okay the every change. So now the array would be 3848, and now we're going to do the same thing. See, we have known that with 3, all these elements and operation is 0. Now we proceed with 4 again. Start would be 3 and nums dot length is not considered again. Here it would be end. Mm, We can take a recursive function. Static void, no, static in, how do we say this? Static function. The input would be the integer nums, start position, end position, and then what do we gonna do? Take this and we use it here. And then what are we gonna do? After this, what are we will be doing is we just checked mm, check whether it's on After this for loop, we got that start is this, end is this. Now we're going to feed this there. Return check on off nums, comma. What would be the start now? It's 8. So start plus 1, comma, end. And what we gonna do? Mm, What is it returning, by the way? It's returning nothing. hmm So what are we gonna do? Going to return something here. Int results would be start minus end, right? The start is 1, end would be 0, 1, 2, 3 plus 1, and minus start 1. Okay. Mhm. This function should give us the result, but how? Hmm, we need to call this recursively. Start plus 1, and so whenever figure, okay, this is the range we figured out in the first one. Now, end is here, start is here. I just pushed what it will do. It will check end operation of, no, it won't go to here. So what I will do, and it should check till end only, no? So end minus minus. What would be the initial end would be? And is means minus minus. Okay, this seems pretty ridiculous. I'm just giving up on this question. Let's look into the interview. Binary search? Seriously? Mm, Code for the software to be nice, use can share set of bits and their values. Then subarray is listed looks determined. However, this should quadratic complexity is suggests to identify subarray, making it too slow for the given constraints. Instead of checking all possible subarrays, we use bind search to find the longest nice subarray. This works because of an important observation. If nice subarray of length k exists, then nice subarray of any length less than k also exists. We simply take a portion of the longer one. Similarly, if we cannot find a nice subarray of length k, then no nice subarray of length greater than k can exist. This monotonic property makes binary search an excellent. Okay, this is binary search on answers pattern, which was similar to yesterday's question, but we failed to do so. Okay, we store it as a candidate for the final result. We check if we find one, we store it as a candidate for the final result. We continue search for the longer lengths. If a subarray of that length does not exist, we reduce our search range and look for the shorter errors. The longest valid length we find becomes our answer. Finally, we need to figure out a way to efficiently check if I have array size. Since we need to track which bits used across the multiple numbers, a bit mask is a perfect tool for this job. As we traverse the potential array, we maintain a single integer, the bit mask, where each bit represents whether the position has been used by any number so far. I don't get it. For example, consider number 4100 in binary and 2010 in binary, and 1001 in binary. As we check each number, we test if any of the bits overlap with our existing bit mask. If there is a overlap, the subarray is no longer nice since two numbers are not shared as a bit. Okay, guys, I don't get this really. In any way, I'm not sure about what's happening. Otherwise, we add current numbers bits into a bit mask using the OR operation. This operation updates our tracing of occupied bit position. If we process the entire subarray without entering overlapping bits, we can confirm that it qualifies as a nice subarray. They want us to look into the binary search explore card and do it. You are in the also have format. If nice subarray of current length exists, update the result to the correct length. Let's run the session what actually longer. So right to that point for shorter math for that. What is a bit mask? Mm. I don't understand this. Let's do it login. Let's train more direct approach. We build our solution by taking larger and larger subarrays until any element breaks the rest. When this happens, we need to remove from the beginning method which method proper. The idea naturally translates to variable size sliding window approach. To check the validity of each window, we can use a similar concept as the previous approach by using the bit mask. the to store all the bits already used in a window. Okay. Point is there is a concept known as bit mask, which I don't know. Even I don't know sliding window, but okay, it's an interesting thing. If there is no overlap, the subarray is no longer nice because two elements now share. If there is an overlap, subarray is no longer nice. You can conflict. When a conflict occurs, you shrink the window from the left by removing the elements until the conflict is resolved. Hmm. Typically, the used bits of this. Okay. If we did an AND operation, if I ended the used bits are 0, 1, 0, 1, 1. I will know. Okay. We can do if we do AND operation, what happens? It should be 0, right? No. I don't know. Okay. If both are same, then only we're going to get a 0, right? So that's how AND works. Here is a 1, here is a 1, and here is a 1. Now here are 1s. No conflict. Okay. Conflict occurred. Mhm. It will get taken. Okay. Mm. Okay. This is not gonna work. Oh, guys, I'm unable to understand this. So, sliding wheel is the best approach that we can do. So that's it, guys. Using a sliding window is required here. I'll make you learn this pattern. Bye. Thank you.